Hey, good morning, everybody. Let's get started. I think we have full agenda today, so let's not. I think we have pretty good forum here. So my name is Gundrala Goud. I work for Microsoft. So I and David and Ron from Google, David from Facebook, we conduct all the OSF activities. And today we wanted to cover the following flow. So I want David to go over the backdrop of OSF, how we came together and what's the history and aspects of it. And I will cover there are two major work streams in this whole initiative. One is the OpenEDK. The other one is the LinuxBoot. I will cover the progress update in terms of the OSF, OpenEDK workstream, and Ron will take over and talk about the Linux workstream. And at the end, Intel made a big stride in terms of solving the key problem for us to enable the OSF community, and Reddy will talk about the FSP module and details around it. So with that, David, you can get.
Hi, everyone. Good morning. So, yep, this is our agenda, which Devendra talked about. So let's just jump right into it. All right, so today we're going to talk about system firmware in this track. And so what is system firmware? What do I mean by that? Firmware is obviously a very overloaded term. So system firmware, in the sense that we'll be talking about, is what brings your silicon to life. It makes that worthless pile of sand and plastic and solder capable of actually running useful programs, as most people know them. Only problem is, code running this early has to deal with a lot of really weird constraints. When your processor starts, processors are actually pretty dumb. They don't know anything about their cache. They don't know anything about their memory. They don't know anything about the devices attached to them. So you actually have to initialize all that stuff. And then once you get through the initialization process, then you get the fun part of loading your operating system target and then executing it. Usually when you want to load your operating system, you want to load it from either local storage or over the network. And then, of course, there's runtime services too, but we'll get into that later. So this has created a few problems. The size of these systems, the complexity of these systems has gotten a lot more, a lot bigger over the years. It's no longer, firmware is something that no longer just simply gets us from point A to point B. There's a lot more boot logic nowadays. But one of the big problems that we've noticed is that who's looking at it? Many engineers only learn about this stuff through necessity, or maybe they have to fix a bug, or they learn about it through security disclosures. So quick poll. Raise your hand if you work with firmware, and this could include things like your IoT projects at home. Okay, now, that's a lot of hands. Keep them raised. So keep your hand raised if you work with firmware professionally, so someone actually pays you to write firmware for something. All right, now keep your hand raised if you've made changes to firmware source code and have built a full bootable firmware image. Okay, right on. Now, this one might be a little controversial. Keep your hand raised if you graduated from college in the last 10 years. All hands went down. So it's kind of funny, but this actually demonstrates a really big problem, which is that these hyperscaler companies have billions and billions of dollars worth of hardware. Who's making sure that the firmware is reliable? So one of the things about opening up this ecosystem is that we're going to be able to draw more people in. We want to be more inclusive. More engineers working at these companies will be able to actually develop, debug, and support firmware. Of course, there are many more aspects we'll get into: telemetry, air handling, security policy, upgrades, and all kinds of interesting customizations. We want to provide the mechanisms that enable OCP users to implement the policies that work best for them. For example, what do you do in case of a hardware error, or a boot failure, or a security issue? Do you boot the machine, or do you brick it? These are decisions that the user needs to be able to make, and for varying deployments. So the goal is not to make the decision for you, but to empower you to make those decisions that fit your deployment best. The use case has evolved over time and has hit the point where this is no longer some small bit of code that can be ignored. Hyperscale companies must take on more responsibility to support firmware in their infrastructure, and we will work openly together to address the modern technological challenges facing us. And we invite everyone to join this effort. And with that, Devender, I'll hand off to the two workstream leads, Devender from Microsoft and then Ron Minnich from Google.
Thanks. Thanks, David. So I don't want to spend too much time on this slide. I think last two OCP summits we have talked in detail, but key points I want to focus on here. So if you see, this is a stack where the currently lot of proprietary code and all companies are having their own work streams and their own products and so on and so forth. Our goal, main goal in the OpenEDK is to transition from this world to that world. And then the key differences between this and that architecturally is around how do we open up the internal initial, after the reset vector, the modules from the various silicon vendors so that they have a clean interfaces to the upper layers. That way, anybody can take the open source of the OSF code and then build around the product bias around that for their own use models. So this is a closed proprietary architecture. Architecture is almost similar in terms of OpenEDK, but the way the code is organized and then the stakeholders, how they are giving the code is different in the other world. So if you notice there, our long-term goal is to come together in terms of the Linux BIOS boot and then OpenEDK BIOS boot, and eventually a single open source for BIOS, so people can cherry pick whatever module they want and interplay between the two different worlds. So that's the long-term goal, but currently what we are focusing on is how can we stabilize the two work streams by working in parallel. So that's where my focus is on OpenEDK, and Ron's focus and David's focus is on the LinuxBoot side of the story. So with that, So here's a quick update. I want to save a lot of time for Reddy so that is the more technical aspects of the project. So I will rush through some of these. So our key main goals in the OpenEDK workstream is basically make the complete tree available for anybody to go download and build it. And with obviously the silicon modules from the silicon vendors with their IP code and whatnot. As much as possible, we are trying to work with silicon vendors so that they can provide as much source code as possible. But there are some things, obviously, in terms of the IP. And then our goal is to have a support for multi-OS and be agnostic to the silicon, underlying silicon. So that's the eventually two major goals we have in this work stream. And in terms of the development progress, I think last time I talked about the first couple of them. The key one, which we are making a lot of progress, is in terms of the, by the way, so when we want to deliver this, it has to be the completely product quality. It's not about a science fair experiment or where we just develop something, right? So our goal is to really focus on the product deployment in the data centers, at least Microsoft, and others can use for their own use models as well. So we are focusing on some of the key features which we care about in the data center. And then the second from the last bullet point is optimizing for performance, reliability, serviceability, and scalability and deployability. So in that, there are some presentations follow on throughout the day in the vein of the debuggability and also serviceability, which is very key. Imagine our use model of cloud is somewhere in any part of the world, and we are trying to manage those nodes remotely. So the key for us is to be able to automatically manage remotely. So that's one of the use models which we are targeting. And right after this, there is a nice concept from Lenovo, Sumit, so please stick around. And then the last bullet is the one which major thing we have done is we have taken all the metadata because the UEFI source, even though it is open, it's all different places. So we collated all that, and we built a document so that it is easy for anybody to go download and then build the open EDKs. Today, you can, we are just uploading the document to GitHub on the OSF website. So as soon as that is done, anybody can go follow those instructions, download the BIOS, and boot a Mount Olympus. There are a few things which still we are working with Intel, but we can compile and then build all the complete BIOS for Mount Olympus. So that will be, everything will be open. So, and the key issue is what I was referring to, and our VP is here from Intel, so Mohan. So this is one of the issue, Mohan, we are working with you, is we can build the OpenEDK completely, and internally we have links for big companies, have links for the open community to build. One of the challenges is to get the ME binary or a workaround around it. So I think that we are working, it should be solved in a week or two. So that's about the open EDK workstream. And I can answer any questions later on, but let me hand off to Ron so that we save some time for Reddy. So.
Just down arrow. So this is LinuxBoot, and I guess it's a nice core boot shirt from Facebook, so I'm wearing it, but I work for Google. So the idea of LinuxBoot is we start with either core boot or U-boot or UEFI or on power, which I forgot to put up here. We have the power firmware, and when you get to the edge of the DRAM being turned on and all the nasty bits of chipset support done, you go right to a Linux kernel, and that Linux kernel has an initram FS. And the initram FS, in the case of Facebook and Google and IT Renew and some others, uses a bunch of tools written in Go. So model is you get the hardware done, right at the edge of that you boot Linux, and then you have Go-based tools. Now, there are people who use older style BusyBox tools written in C, but it's safe to say in general it's the Go-based tools. And then from there, we have Pixie boot written in Go, or booting over HTTPS written in Go, and we can parse syslinux and grub config files, so we can also boot from disk. So all the boot happens because of Linux, and the last stage is you do a kexec. So that's kind of the basic model. LinuxBoot has been deployed, and most of it's been deployed in the form of that thing I mentioned with the initram FS using the Go-based tools. There are a couple cloud providers, manufacturers, and an aerospace company that have it. There's actually a company, and I wish I could name them, that builds cars, and the machines running the manufacturing line all run LinuxBoot. It's in evaluation, an IoT vendor. I wish I could say more, but people can't quite let me release that yet. Intel fixed the licensing for FSP, which was a really great thing. It happened last year, and that meant that FSP blobs now get redistributed under the same good license as the microcode. As Devender mentioned, we're dealing with a few licensing issues still with the Intel ACMs and the ME blobs, and I'm happy to hear that that might be getting fixed. We don't know the status of some of the other vendor blobs. We're not quite sure about AMD because AMD is not quite joined this party yet. We would love them to, but they're not. They're kind of haven't joined the project. We have had some pretty good ARM representation, which is very good. This last bullet has changed a lot. It started as starting to be a problem. BootGuard went to maybe a problem and ended up as BootGuard is a problem. So the basic model of BootGuard is the company that makes your computer owns your firmware updates for the life of the machine. And if you think about Open Systems Firmware, which means you can load your own firmware after building it, BootGuard and Open Systems Firmware are fundamentally at odds. They are not compatible. You really have to buy machines with BootGuard disabled. We learned yesterday, much to our delight, that when you buy systems from Lenovo, you can order an SKU where BootGuard is disabled. We have not heard that from any other manufacturers yet, but I think that Lenovo has really set the stage here to do good things. I should also mention that the final company I forgot to mention, Lenovo recently demonstrated that they can build the Linux kernel, build our Go-based tools, put them in firmware on the HR630X server and have it work. So that was kind of a nice thing. They did that work in just a few days, having never seen any of the code before. So that tells you two things. Lenovo is really smart, which we already knew, and the software is actually pretty easy to build. Okay, finally, goals. If you're an ODM or you're an independent BIOS vendor, or if you're a chip maker, we want you involved. In the same way you're involved in Linux, we want you involved in this. We want to build a good open source ecosystem around LinuxBoot. That's our goal. We share that goal with Microsoft, but obviously a different thing. We want ODMs to ship Open Systems Firmware by default, and to that end, we're hoping that at some point in 2021, the only way you get badging for your OCP hardware is if it runs Open Systems Firmware. That's the target. We have people who'd like the ACM source to be ACM to be available as source with reproducible builds. And again, Open System Firmware badging is going to include BootGuard disabled, basically, and other proprietary technologies made optional. And I'm really happy to hear we may be close to resolving the ME blob distribution problem, but that has to be basically resolved for every blob that's in the system. Now, questions later, and I need to move on to our speaker from Intel.
Thank you. Thanks, Ron. Okay. Can you guys hear me? Good. How many of you heard about Intel Firmware Support Package before? Okay, reasonably good number. So I probably don't have to go into the details. So I'm going to focus mostly on a lot of focus for the Intel Firmware Support Package has been on the client platforms. Now, my talk is all about what exactly are we doing on the Xeon Scalable processor, specifically on the 2-socket platforms and 4-socket platforms. We need to be able to do certain things within the context of firmware support package, so we can actually easily integrate into the bootloaders. So brief background on the Intel Firmware Support Package. What exactly is this? So if you look at the Intel Firmware Support Package, it essentially provides 3 different parts of initialization. So the processor initialization, chipset part, and the bigger one is also in memory part, right? So it essentially takes care of the complex initialization steps and abstracts them through well-defined interfaces that you can actually use to integrate with the bootloader. So the key thing to remember is the Intel FSP package is not really a full-blown, full-functional bootloader. It is really meant to be able to use that as a binary blob, integrate with the bootloaders to actually do the boot steps, platform initialization, bring up the OS. All those things are outside the scope of Intel Firmware Support Package. You can also you won't be able to do the ACPI initialization, for example, say the advanced RAS. All those features are not really part of the Intel FSP package. If you click down on the Intel FSP blobs, there are 3 different broad groupings of functionality. So the first one is the temporary RAM initialization, where it is actually taking the cache, setting up as RAM. And then the next one is the memory initialization part, tearing down the cache as RAM portion. Then the third one is the silicon initialization, where you are actually initializing the processor side, doing some portion of the early part of the device, PCIe, uncore part of the initialization, and then you essentially have interfaces to notify the boot loader to finish off certain steps so that you can actually lock certain regions before you boot into operating system. The primary interface between the FSP and the bootloader is really a set of data structures called handoff blocks. So these handoff blocks will be different for different platforms. So you'll have to look at what exactly is different for each platform, and you'll have to look at the spec, and you'll have to consume it that way. Okay, so clicking down, there are a lot of steps that happen, but the stuff that is actually in blue is actually part of the bootloader logic. The initialization part, getting into the reset vector, switching over to 32-bit mode happens in the bootloader, and then you connect with the FSP blob through temp parameter API calls, and then actually go through that phase. Then you actually jump into the memory initialization phase on the right-hand side, and then there is also the silicon initialization phase. Okay, so what exactly are we trying to do within the context of Xeon processors, specifically for the multi-socket platforms? So there are lots of nuances that we need to worry about when it comes to multi-socket. The first and foremost, obviously, you have UPI lanes. So the whole initialization discovery of other processors sitting on the different sockets, you'll have to go through the MP multiprocessor initialization steps. You will have to initialize the KTI lanes. You'll have to actually discover the other processors, and then you'll have to bootstrap, and then you'll have to start executing the code for the reset vector. So there are lots of steps that happen behind the scenes that you are really not aware of. FSP package actually buries those details for you and nicely abstracts and initializes everything for you in the multiprocessor type of environment. There is also MRC, parallel MRC, where you have each socket, it has its own DIMM modules. You will have to go through the MRC initialization phase that has to be done by each socket, and there is a coordination that you need to worry about. So that's also a critical step. And then there are certain things that you have to do in the pre and post for the integrated I/O portion of the processors in each one of those sockets. And then obviously you need to worry about some of the platform abstraction, especially for multi-socket platforms where you have interleaving, for example. There are lots of nuances that you need to worry about when it comes to interleaving, local, channel level, socket level, and all that stuff that you need to think about when you actually do the integration with the bootloaders. Okay, so where are we within the context of what we are trying to achieve? I was hoping that I could actually do the demo today, but unfortunately, it was a very bold goal for us to actually get to a functional POC. So we are kind of somewhere around maybe 40, 50% of the progress so far. And we'll come back to the community and update on where we are. But we are working with Facebook. David and Jonathan are here. Our goal is to actually bring up, integrate the firmware support package with the two-socket Tioga pass with core boot and make sure it actually works. And our hope and pray is that based on that, we'll essentially look for what is the best way to evolve the server side of the FSP package for the bootloader integration. Okay. All right, that was my last slide. Sorry, I had to rush because I had only like 4 or 5 minutes. If you have any questions, I can answer later. Devendra?
Yeah, you did pretty good. So you have 4 minutes, and Ron, you can step in. So any questions, we are happy to answer in next 5 minutes.
That was a wonderful talk.
Yeah.
The FSP, is that source distribution or binary form?
Binary.
Are you saying that proudly or with?
So the current plan is binary. So the question is FSP the binary or the source-based, right? Is that the question? Yeah. The response is currently it is binary. That's all I can speak at this time.
So I guess we can be a little more optimistic than that, but not much. Raja Kaduri, one of the top leaders at Intel, did say in a comment that we are looking into open sourcing the FSP itself, but it's the early stages of looking into. So the answer of when can I expect one is we have no idea.
I'm glad to see Isaac here. So this Skylake FSP, is it just for Facebook or for everybody?
I don't think we can talk about that.
No, I think my understanding is the POC is being done with Facebook and LinuxBoot Stream. But once that POC is there, it's pretty straightforward to incorporate in any platform.
This should also help the MIM platform and EDK. Oh, so this work we're doing will hopefully also help benefit people who want to use the MIM platform and EDK too as well. So you'll be able to integrate it into your UEFI firmware if that's the path you want to go. I think that's about it. Oh, one more?
For the Open EDK2, is it based on TNO core, right? So Intel support?
Yeah, so the current methodology is, we leverage from Tiano Core repositories, but they did create a separate work stream for Min platform, OpenEDK. So that's the reason I was mentioning we put together a document with Intel so that using those instructions through GitHub, you can download the entire package from different sources. So that's what we are going through. So.
Yeah, and we're not actively keeping the Perly min platform up to date. That was proof of concept once. For Cooper Lake in future, we're looking to have this be the POR and fully supported and updated post-launch. So we're working to make that happen, but today it's not. And we haven't even really worked out like labeling the min platform and things like that. So we're working to get it into the master and get it into CI and things. So the Perly one is shaky.
So any questions for LinuxBoot, Ron, and anybody? I think it looks like a lot of you have 5 questions.
Yeah, no, we probably have time later. We're happy to talk.
Yeah. Yes, by the way, yesterday we had a really nice, very good sync from different stakeholders. So I captured all the pain points of the ODMs and how we can help the community. So the call for action for each of you guys is I encourage strongly to hop on to Open Compute, and you'll find the dial-in details for a bi-weekly meeting. We always have that. I think most of you join, but more people is better for contribution. So.
Oh, I just want to say again, as Devender just said, if you're in this business, and we'd love to have you on the bi-weekly calls, and we'd like to get you engaged any way we can. So, just to confirm that. Thank you.